All right, let's dive into one of the biggest and I think most overlooked challenges in AI today, memory. It's kind of the secret sauce, the hidden architecture that decides if an AI agent is going to be a truly brilliant collaborator or just another forgetful tool. So let's get into how it all works.
I mean, this quote from the report just hits home, doesn't it? We've all been there. That feeling of complete exasperation when you have to explain the same thing all over again. Well, that is the daily reality for developers building AI agents. This amnesia is the absolute core problem we're going to unpack.
And that really gets to the heart of it. Without a persistent memory, every single time you talk to an agent, you're starting from square one. It turns what should be a collaboration into this frustrating loop of just re-explaining context again and again and again.
So here's the crucial takeaway, and really the main argument of this whole report. You can have the most powerful, most advanced large language model in the world, but it doesn't matter a bit if it has the memory of a goldfish. The real game changer, the thing that creates a genuine AI partner, is all about the sophistication of its memory.
Now you might be thinking, look, we've been managing data in databases for decades. How hard can this really be? But, as we're about to see, agent memory is a completely different beast. It's built on principles that are almost alien to the way we've traditionally thought about data.
And this slide just paints the picture perfectly. On one side, you've got the super predictable, clean world of a traditional database. You ask for customer number 123, you get customer number 123 every single time. On the other side, you have the wild, messy, non-deterministic world of AI memory. It's fuzzy, it's unpredictable, and it's all about finding meaning, not just an exact keyword match.
And the challenges here are pretty huge. These agents are trying to find concepts, not just text. They have a really limited working memory. That's the context window. And maybe most importantly, they have to constantly make these tough judgment calls about what's important enough to keep and what's okay to forget. Okay, so if it's that hard, how in the world do engineers actually build a functional memory for an AI? Well, the goal isn't to create a perfect memory, but an intelligent one. And the design you'll see often borrows ideas from the most complex memory system we know, the human brain. You know, just like our own minds, an AI's memory isn't just one big bucket. It's split into categories. You have episodic memory, which holds specific past events, like our last chat about the Q3 report. Then there's semantic memory, which stores general facts like what a Q3 report is. And finally, procedural memory, which is all about learned skills, like how to actually generate that Q3 report. To manage all this, engineers have come up with a really clever toolkit. They use importance scoring to rank memories, kind of like how you remember your anniversary, but not what you had for lunch last Tuesday. They use semantic caching to keep frequently needed info close at hand, and they use intelligent compression to basically summarize old conversations, which saves a ton of space. But how does an agent even begin to know what's important in a conversation? Well, one of the most powerful tools is something called named entity recognition, or NER. Think of it like a superpower that lets the AI read messy, unstructured text and instantly pull out the key players, the people, the places, the dates, and turn all that chaos into neat, organized data. So this process totally transforms how the AI finds things. Take a vague question like, what did John say about the budget? First, NER extracts the entities, the person John, and the topic budget. Then it uses those structured tags to run a super specific filtered search of its memory. This is the difference between fumbling around with keywords and making a precise, surgical strike to get the right information. So far, we've been talking about a single agent's brain. But the real magic, the future of all of this, is when we start connecting these individual memories together into a shared organizational intelligence. We're moving from a personal assistant to a collective brain. In psychology, this concept is called a transactive memory system. You know, in a human team, it's that unspoken knowledge that Sarah is the go-to person for marketing data. Well, AI agents can build a digital version of this for an entire company, creating a true group mind where everyone's expertise is available to everyone else.
And this isn't just theory. The impact is proven. A study from 2023 found that when they gave novice call center workers an AI assistant that had access to this shared knowledge, their productivity shot up by a massive 34%. It basically leveled the playing field overnight.
So this technology is doing so much more than just storing data. It's actually capturing the problem-solving skills and the know-how of top performers and making all of that expertise available to everybody.
It's a huge shift from knowledge being trapped in silos with a few individuals to it becoming a living, breathing asset for the whole organization.
And that leads us to this final, really thought-provoking question from the report. As these memory systems get more and more powerful, storing and connecting this vast collective intelligence, our role, it changes. The technology might provide the orchestra, but it's still going to need a conductor. It's up to us, the humans, to provide the vision, to set the direction, and to ultimately decide what success even looks like. The future of memory isn't just about what our agents remember. It's about what we choose to teach them.